Why don't we get started? So welcome all of you to this webinar, which is going to be featuring some of our master's programs. We are delighted today to have on the call Dr. Tanya Khanna and Dr. Kanta. They are both amazing program directors for our electrical engineering and also material science and engineering programs. It's wonderful to see all of you on the call. And uh, in this webinar, we'll not only tell you about these programs, but also keep some time for you to ask questions. But if along the way you feel like you have any questions you want to ask, feel free to put it in the Q&A and we will get to them along the way. So again, thank you so much all for coming. It's wonderful to see the large number of attendees. And I'm going to kick this off by handing this off to Dr. Tanya Khanna, who's going to tell us about the Electrical Engineering Master's Program.
Thanks, Boone. Like Boone said, I'm Dr. Tanya Khanna. I'm the Master's Director, Master's Program in Electrical Engineering Program Director. So, I'm the person that you would come to if you want advice on what your career path should be, what courses you should take to market yourself and to propel yourself on that path. But let me share my slides for our program and we'll get started. Okay, let's see. All right. I hope you can see them.
Yeah, they're all good.
Okay, good. All right. So like I said, I'm the Electrical Engineering MSE Program Director. So just some details about it, just some specifics. So again, the title, Electrical Engineering, and the program description, right? It gives you the theoretical foundation and interdisciplinary skills. And I want to highlight skills. We try to make sure that all of our classes have skill-based learning in them to prepare you for anything you might do after. To deal with new ideas, new applications that are hallmarks of modern electroscience, and all of the adjacent fields, right? EE is such a broad field that no matter what your interests are, we're going to be able to cover that. So a major advantage of the program, it allows you to tailor your education to your own interests and goals. Like I said, it's such a broad field. It covers such a wide variety of interests that you could be interested in electromagnetics, photonics, sensors, MEMS, VLSI, nanotechnology, data science, right? It's got such a wide breadth that it enables you to really focus on your interests. Our student population is approximately 250 students. A little more than that is a little more than half of that are new students, and then we've got the rest that are continuing students. We've also got in there accelerated master students. So that's the size, the general overview of the program. Some details, right? If we get into the details of the actual program, what the curriculum looks like, we basically have these 4 categories of courses. Category A, that's your EE core courses. Those are your 5 EE core courses, and you can choose from 32 approved choices. So there's a lot of flexibility in there. We have 32 already approved choices, but you can always petition for any other course if you feel like you want to tailor it to your own needs and interests. We've pre-divided them into these 3 categories: physical devices, nanosystems, circuits and computer engineering, and information and decision systems. But you could take any combination of them. You don't have to be all in one of these areas or vice versa, right? And we've got some very, exciting classes in all of these, in all of these areas, right? In nano systems and devices, we've got quantum circuits, quantum engineering, nanofabrication, optical theory. So it's a wide breadth. Circuits and computer engineering, that's really exciting right now. We've got all of your analog and digital VLSI circuits classes, system on a chip architecture, hardware software co-design for machine learning. And there's a very exciting new class this semester, chips design, where it's actually a 2-class series. The first class, you actually get to completely design a digital analog or mixed signal VLSI system. You design it, you test it, you simulate it, you lay it out, you test for post layout simulation, and then it actually gets sent for manufacturing. It'll come back over the summer while you're doing your internships. And in the next fall, you'll actually get that physical chip back and you'll test it in another course which is chips testing. That's a really unique experience, and it's going to be very interesting and very exciting. We've also got power electronics in that field. It's also a very exciting new course. We're continuously adding new courses, right? As we see where the industry is going, as we get more faculty, new courses are always being added. And then, of course, information and decision systems. We've got exciting classes in there. The usual standards, linear system theory, feedback design, optimization, which I have a kind of sore spot for in my heart. I always advise any engineering student to take an optimization class. It's kind of the driving force behind why we do what we do, the techniques and strategies we do. But encompassed in there are all your data science classes as well: statistics for data science, deep learning, graph neural networks. As you can see, right, there's a wide breadth of topics within our curriculum, and you have the flexibility to choose where you want to go. That being said, I and all the faculty will advise you to kind of look at your grouping of courses to make sure that you're preparing yourself for what you want to do after, right? That's what we try to guide you on how to choose from this large set of classes. After you do your core classes, you are allowed 2 EE electives, which is any graduate level electrical engineering offered course. And then category C is any C's elective, so any graduate level course within engineering. So you can be in, a lot of students take classes in mechanical engineering and material science. We have represented from material science here today, robotics, in mechanical engineering, in bioengineering. You have a lot of choices there. And then category D, you have to do these 2 free electives. As long as they have some technical content, there's a large list of approved electives. Many students go to Wharton, take classes. Many students go to the law school or in the art school, or students will take other engineering classes, right? Any category A class can be counted in any category. So, that's the idea, is that we want to make sure that you have the flexibility to really explore your interests. And not only that, explore some adjacent interests, right? A lot of times students will come to me and say, I want to take 10 classes in machine learning. Well, we don't have 10 classes in machine learning, and we want to make sure that you have a variety of knowledge or breadth of knowledge. So we'll encourage you to really explore some of the other areas. But for the full information, there's some links here. The master's in EE information, you can get a full listing of these category A classes there. The course planning guide tells you exactly what the degree requirements are. And then, of course, the ESE course catalog, which lists all of the courses offered within ESE. So those are some useful links there, and you can always find those and look at those. So just to kind of talk about what are the other opportunities outside of the curriculum, right? As part of the curriculum, you can also utilize these excuse me, special courses of doing a independent study with a faculty member or doing a thesis. So you could do research with our faculty, right? That's one of the benefits of coming to Penn, is within ESE, within our department, the opportunities to work with our world-class faculty in research or as an independent study in all of the areas of research they have, right? Motion capture, swarm and nanotechnologies, very exciting stuff happening with robotics and EE, cyber physical systems integration, meta nanocircuits, urban transit, mobile solar power, prosthetic device enhancements, personalized medicine, and food and water security, and more, right? Here's the listing of some of the research and lab centers affiliated with ESE, right? We've got the GRASS lab, that's our general robotics lab. Precise, those are probably the 2 that you've heard most of. Precise is our embedded computing and integrated systems engineering. So a lot of exciting stuff. We've also got our Sing Center for nanotechnology. If you take one of those nanofabrication classes, you'll be in there fabricating. Warren Center for Network and Data Sciences. And then a couple of kind of newer ones, the Center for Precision Engineering for Health. That's trying to ramp up right now. It's motivating personalized medicine, doing a lot of molecular engineering in there. Internet of Things for Agriculture, that's working on that food, energy, and water security, kind of implementing our technology into those industry to make them more efficient and more accessible for all. And again, there's a link there. You can learn more about these centers and institutes of research, right? Again, that's kind of the benefit of being at a place like Penn versus somewhere else is that you get access to all of the community at Penn. So, I mentioned after Penn, depending on what your interests are, you might want to go into academia or industry, right? And so, our curriculum, our flexible curriculum, like I said, it enables you to kind of choose your own courses, within our advising guidelines, to market yourself for the job you want to have, right? So, some companies that hire students, Facebook, Oracle, Microsoft, the usuals, Huawei, Qualcomm, Google, Apple, Amazon. Those are the general, engineering or technology oriented ones. People also end up at McKinsey, IMC Trading. There's been some new interest with Tesla. Two of my TAs currently, they work at Tesla. One of them is ending up at MIT Lincoln Labs next year. So these are the kind of industry that our students end up in. And then, of course, you can also further your education in academia. So I personally write, probably 5 to 7 recommendations every year. And the, university PhD program students have joined that I've, been notified of Cornell, UPenn, CU Boulder, UT Dallas, Northwestern. And I will say that, a lot of the students, they'll ask me for recommendation letters and they'll say I'm applying to Penn, and I'll encourage them to apply elsewhere, but a lot of them stay at Penn because they're doing research as a master's student and they want to continue that research with their faculty member here. So that's just kind of an overview of the program. I'm happy to answer questions now, or I don't know if there's a Q&A session later. I don't know if there are already questions. I'll
Yeah.
let you, yeah.
Thank you, Dr. Tanya. We'll have a Q&A at the end, but I thought there are one or two um, specific to ESC questions that came out that will be great to answer live. So there was a student that asked about information on thesis or project courses, particularly in EE. So maybe you can speak a bit about EE master students pursuing the thesis option or working on research with faculty.
Yeah, so a lot of times students will ask, let me stop this sharing. I'll keep it up. So a lot of times students will ask me, how do I get that opportunity? How do I start that research thesis? The first way to do it is take a class with a professor you're interested in doing work with. That's the first thing you do. There's no necessarily sign up sheet where we'll match you. You have to go and talk to the faculty members, show them that you're interested in their research by reading their papers, talking to their students, taking their class. And then once you talk with them, oftentimes you can propose a topic, or they might have a project that they need a student to work on, and they'll work with you to do that project. And then you can register for 1 or 2 CUs of thesis credit, whatever your choice is, or whatever you talk with your faculty supervisor about. And then you would do research with them. And for the thesis option, you are supposed to write a thesis. Independent study, you don't have to write a thesis, but you still work with the faculty member. So I don't know if I answered that question.
That's a great answer. Thank you, Dr. Tanya. So I think we will defer additional questions to the end. I'd like to hand the token next to Professor Ani Xie. She just joined a few minutes ago, and she's going to be talking about the Masters of Robotics programs. And so Ani, I'm going to hand it off to you.
Great, thank you so much, and I apologize for being a few minutes late. So I am Ani Xie. I'm the Deputy Director of the General Robotics, Automation, Sensing, and Perception, or GRASP Lab. I'm also an Associate Professor in the Mechanical Engineering and Applied Mechanics. So for those of you who do end up coming to Penn as Robo MSE students, I will be the person who basically puts a lot of signatures, my signatures on your forms, basically. But just to give you a quick overview today, let me make sure we can, okay. So GRASP was founded in 1979 by Dr. Rujana Bacci. Dr. Bacci is back at Penn, and so you will actually see her around campus because she will join, she comes to all the various GRASP events. So I think the numbers here are a little bit out of date, but we just recently went up to 23 primary faculty members with about 10 secondary faculty members. The primary faculty members come predominantly from mechanical engineering and applied mechanics, computer information sciences, as well as electrical and systems engineering. Secondary faculty comes from other departments within engineering, as well as all throughout the university. So we have faculty from School of Medicine, School of Nursing, School of Architecture and Design, and as well as other sort of departments all around campus. And we have approximately around 19 research staff. And this includes postdocs as well as engineering staff, about 130 something PhD students, and our Robo MSE numbers are around 230-ish. That number kind of goes up and down because we also include our accelerated master's students who are our undergrads who are doing the 4+1 sort of program where they get their BSE as well as their MSE within those 5 years. So what I'm showing you here is some of the facilities that we have. Currently, the lab is split across main campus as well as the space at Pennovation campus, which we will talk about, which I'll show you in a little bit. So the way I like to describe to people about the scope of the work that the GRASP faculty is engaged in, if you can think about a robot that walks, that drives, that flies, that swims, whether it is measured in terms of nanometers or microns, all the way to sort of multiple meters, right? We do it all effectively. And so this is sort of shown to you by all the different areas in robotics that our faculty maintains expertise in. So as I mentioned, we are currently, sort of split in between main campus and Pennovation. So the way I would normally describe the distinction is that Pennovation is this offsite incubator space. It actually has enough open area. And so this is where a lot of the field robotics folks are situated because we can actually fly the drones, we can actually deploy our autonomous boat out on the river, as well as, walk our walking robots. And so in many ways, right, sort of the split has more to do based on the different types of research that is conducted. One thing I will also note is that we have a new Robo MSE project space, and I'll talk more about that when I go over the curriculum. And that project space is also situated at Pennovation. So you'll see why in a little bit. Okay, so this is a 10 credit unit program. You must complete 3 CUs in, out of the 4 foundational areas. And so the 4 foundational areas are AI, robot design, and analysis. Let me make sure that this movie plays. I think I tried it earlier, but if not, so you can actually go onto YouTube and go onto the GRASP Lab channel. This is just to show, this is the project course, MEME 5100, Mechatronics. This is usually taught by Professor Mark Yim. And every year you have to build a robot and actually get the robot to execute some kind of a task. And this is and then, the different teams will compete in a competition. So the foundational areas, let me just finish going through those. This is AI, robot design and analysis, control and perception. From there, you have 5 technical elective CUs that you can choose, as well as 2 general elective CUs. The program is set up so that you actually have 3 options. You can do a course-only MSE program, you can do a thesis-based program, or you can do what we call this new Robo Capstone Project program. So if you do course only, you just kind of have to follow, right, sort of the general outline that I provided to you on your left-hand side. If you're interested in doing thesis, this would be an independent sort of research-based, right, work that is conducted with advising from a GRASP primary faculty or a, GRASP secondary faculty co-advised with the GRASP primary faculty. The new RoboCapstone project, so this is a project that would be considered a group project. So the idea here is if you have a project that is larger in scope, right, than something, that a thesis that doesn't quite fit a thesis as well, because it's a larger scope project, because it might actually be more focused on sort of developing, taking, novel research, but really now applying to a very specific application, then a capstone is oftentimes a more suitable option rather than a thesis. In addition, often, we currently at GRASP have just kicked off a new corporate affiliates program. And so the view is that these capstone projects can also be collaborations, right, between students, GRASP faculty, as well as corporate partners, okay? So the links are below for more information about the courses, as well as the different, what the technical electives and what the general electives are. So this is the virtual lab tour. You can go online. I provide the link on top. Again, this is on the GRASP YouTube channel. You should be able to search for this. It's a little bit dated now because the video was taken during the summer of 2020. And this was before the new Robo project space has come online. So right now, the new Robo project space, right? So this is meant for people who are conducting Robo capstone projects, Robo thesis. And then we have different faculty, right, that have specialized equipment that is specifically designated for some of these projects. And that's essentially where it's housed. So what you're seeing, this is the small Levine 457. Advanced Robotics, which is MEME 6200, is going to be conducted, the projects are conducted in this space. This is where we fly the quads through an obstacle course. The space is, this is one of the many Vicon instrumented spaces that is available to people at GRASP, okay? And so I will move on and sort of let you guys watch this at your own time. And the last thing I just wanted to end on, so that, GRASP is a really large community. If you sort of just look at the numbers, right? So we're, graduating 60, 70 Robo MSE students every year. We are also, in addition to the PhDs, as well as postdocs, and people who then go on to be faculty, to work in industry, and so on and so forth. And so because of this, we actually have a lot of stuff going on campus. We have weekly seminar series. We have the GRASP on Robotics, which is usually on Friday. We have the student faculty industry, or the SFI series. This is a 100% student-run seminar series. The students pick, the speakers. They do send out the invitations. They arrange the schedules. And so this is an opportunity for students to get involved. We also host annual industry days. So this year we hosted our industry day in the new Robo space. And this is now an opportunity for industry to tell us, right, what are the interesting problems that they're working on, and in addition, get a chance to network with our students, with our faculty, and then and this is in addition to sort of the biannual resume books that we put out and we share with our industry partners. We have a lot of student-run committees and student-organized social events. And our alum, some of them go on to other to PhD programs. A lot of them have sort of started companies, right? And so some of these should be pretty familiar. In fact, Ghost just hit another big milestone, and then and then a lot of them go into the usual industries. A lot of the places that you would associate who do robotics. So I'm going to be here, and I'm happy to take any questions.
Thank you, Ani. So there were two questions that are specific. Actually, there are more than that, but I thought there are two that will be interesting to answer for you to answer live. So there was a student asking about TA and RA opportunities in the robotics master's programs. Could you maybe speak to what's the best way for students to find them, get faculty interest and so on?
So TAs, these are all sort of managed by the faculty who's teaching the course. So normally you will figure out, you've probably taken that course. And so I always encourage you to just send an email out to the faculty if you're interested in TAing that course. We are always looking for TA. So TAs are, at least at Penn, these are paid sort of on a hourly basis. Okay. So, and then depending on the structure of the course, different instructors will, manage TAs and sort of think about what kinds of responsibilities, right, or, the way the responsibilities are distributed is going to be dependent on the instructor that teaches that particular course. RAs are also possible, but this is now, there's no, first of all our PhD students, have research assistantships, but it is, there is research opportunities or paid research opportunities for Robo MSE students. Most of these, I think all of them are basically, if they're paid also on an hourly basis, okay? The thing is you can do research, either as a paid research assistant, you can also do this as independent study for credit, right? Or you can also do this in terms of either in the form of thesis or capstone. So this is something that you have to reach out to the individual faculty that you're interested in working with, and then basically, talk to them about the range of opportunities that they, are able to provide.
Cool. Thank you, Ani. So the next question is, if students provide maybe like a GitHub project portfolio, would that be valued in the robotics application review process?
It depends. So, we have a lot of applications. And so, yes, that we do look at everything, okay? But it really depends on, so we take a lot of different, we do assessment on multiple axes, and that is just one of them, right? But I would say that, this is a very competitive program. And so, things that I think you should just, put your best foot forward and try to fit as much in your application material as possible. Anything that requires us to actually have to do extra work to go find and learn about these projects, it's a lot of applications. And so we really cannot do that for everyone.
Cool. Thank you, Ani. So, I think there are other questions, but we could defer them to the later part of the webinar. So I'd like to hand off the token next to Dr. Kanta, who's going to tell us about the Material Science and Engineering Master's Program. So Kanta, floor is yours.
Thank you, Boone. I think everybody can hear me. Let me just share screen. A very warm welcome to all the participants. I've been trying to answer some of your questions if it pertains to material science and engineering. So a big hello to all of you. My name is Mahadevan Kanta, and I'm the program director of the material science program. And my intention in the next 10-12 minutes is to give you an overview of our master's program, tell you about the faculty and our staff who have been instrumental in raising the profile of our master's program to be rated in the top 10% of the master's programs in the country. It's one of the oldest master's program as well. So let me begin by giving you a glimpse of who we are and what we do, and then talk specifically about the master's program. So our chair is Professor Shu Yang, and our graduate group chair is Professor Eric Stack. Both of them are not able to join today because we have our departmental seminar at this time. And let me share this like this. Sorry about that. So this is a glimpse of our primary faculty, and it's actually missing one member of the faculty who has just joined last week, Professor Ling Li. So I'm sorry, I do not have a profile picture of him. And I'm going to give you a little glimpse of what each of the faculty member works on and what is material science. The meaning of material science has expanded so much in the last decade or two. When I first joined this department more than 3 decades ago, it used to be a very traditional materials field. You made materials, you studied materials, you tried to understand their properties, and it was specifically in the realm of electronic materials, structural materials, and then new exciting discoveries happened, and a lot of interdisciplinary collaboration set in. So now what is material science is very different from what it used to be. Now we are doing a lot of material science research for biomaterial applications, which is a very new thing. We are also doing materials research to combat the effects of global warming and so on by understanding the societal needs and trying to come up with novel architectured materials, taking our inspiration from everything from biomimetics, from organisms that have evolved with a host of interesting material properties, and our quest is, can we replicate that in the lab and actually implant it not only in the human body, but even perhaps design clothes and windows of buildings that would, in a way, combat global warming and the effects of climate change. So that is what material science is all about. There are principal areas currently that are being pursued in the department, can fall into these broad 6 categories. That is materials for energy, a hugely important endeavor all across the world. Materials for health sciences that I just alluded to. Sustainability is, of course, also a very important focus in the last 2 decades, a lot more now than before. And of course, these have always been the bedrock foundational material science, structural materials, electronic, optical, and magnetic materials, and polymers and soft materials. So now the emphasis is to harness our knowledge and experience that mankind has gained from these traditional materials and use them to address societal needs and human needs. There are also 2 broad areas of research in material science that encompass all these categories. One is how do you study materials? We usually have to look at the nanoscopic scale, and there are lots of microscopy and scattering techniques, and we have some of the world's leading experts here. And there is also a great deal of emphasis now on computational material science, just because fabricating materials is expensive. And even though I do not have a specific block for using machine learning and AI, that part of research has also expanded in the department, because just as in other fields, machine learning seems to be able to guide us narrow down the choices of materials that might be applicable for any one of these applications, and then it could help us guide its synthesis and analysis. So let me give you a little bit detail into what these buzzwords are. I'm going to begin with the most exciting piece of news that we all received in October of last year, when the Nobel Prize in Chemistry was awarded to this trio, Professor Bawendi, Professor Bruce, and Professor Ekimov, for their research on quantum dots that you probably all have in your TV screens. And this research was spearheaded by Professor Chris Murray when he started as Professor Bawendi's first graduate student. This is the paper that was cited by the Nobel citation in awarding the prize to Professor Bawendi. And this was hugely exciting for us, because this is probably the closest you can get to a Nobel laureate, is by having one of our primary faculty listed as the listed as the person who did the work that laid the foundation for this field. So that was great excitement. I mentioned about microscopy tools, and Professor Eric Stack leads that. There is a great deal of research done by Professor Agarwal and Professor Feng, who are world-renowned in developing quantum materials for all kinds of applications and lasers. And the materials for energy group is led by Professor Eric Detsey, Professor Eric Stack, Professor Composto, among others. The materials for health is a newer initiative where we have had new faculty. I couldn't put in their pictures here. Professor Chris Mandel, Professor Yuan Wen Jiang, and Professor Vivek Shenoy, who has his own center for biohealth applications. Sustainable materials is being pursued by Professor Xu Yang, Professor Liang Feng, among others. So it's a very exciting time to come to material science. And what type of students do we look for? Previously, students used to come with a material science background, but no longer, because the applications are so diverse now. We get students who have definitely an engineering background sometimes, like mechanical engineering, electrical engineering, chemical sometimes, bioengineering. We also get people from very different disciplines. Physics and chemistry have always fed into material science, being the basic sciences. We also get people who are interested in doing architectural applications, but evolving materials for sustainable architectures and so on. So we get students from design sometimes. We get students from biology, because as I told you, that many of the materials, the new materials that are being developed, are no longer just restricted to structural materials or electronic materials. It's putting together an architecture that takes its inspiration from living creatures. So people with biological backgrounds are increasingly coming into material science. So no matter what your background, you're welcome to apply to the program, and we will evaluate your suitability. We have several faculty in leadership. These are listed here. You will also find this listed under the faculty website. So I'm just going to go very quickly. I want to mention that you've already heard two insightful presentations by Professor Khanna and Professor Anisi. Those programs are a lot bigger than material science. And material science, the size of the primary faculty is only about 15. But we have a lot of secondary faculty and a very large graduate group. But the faculty have been instrumental in garnering a number of awards for excellence in research that's given by the school. We have had some teaching awards too, and so on. And a large percentage of the material science faculty possess endowed chairs, which is a mark of recognition that they do at Penn. I also want to focus here on our long dedicated staff members that we are very proud. The Material Science Department has the graduate program coordinator is Ms. Irene Clements, and it's very rare for one employee to serve in one department for over 50 years. And this was several years ago. And some of you may have written to Ms. Clements requesting information. So she is the graduate program coordinator, and she's assisted by other staff members who handle other parts of the MSE logistics. And then I want to attract you to the University of Pennsylvania, because we are next door to the most beautiful building on campus, which is the Krishna Singh Center for Nanotechnology, where a lot of material science faculty and students do research. So we are just where this building ends is where material science begins. And now I want to go briefly into the specific details about the Masters in Material Science program. I saw some questions from the audience requesting information, so I hope you're still around. Otherwise, the recording will definitely be posted. So as the others mentioned for their programs in ESE and robotics, the intention of this master's program is to give you a broad foundation into what material science is today, and give you enough expertise so that you can branch off once you graduate, either into industry or into research or in startup companies that you may want to start on your own, or even go into consulting. And consulting is also acquiring a lot of material science expertise, as many of the consulting houses deal with the need for technical knowledge so that they can make good investment decisions. And there is nothing like a technical degree. Our student population, as I mentioned, our department is small, so the student population is also not as big as the other two programs that were featured today. So we have about 77 students in all right now, and about 10 to 20% of students do a dual degree in master's dual degree, and some of the very popular majors where students have been successful in doing a dual degree are listed here. This is a profile of how many students graduated in May 2023, August, and in December. And these numbers vary, but we are expecting a nice class of about 25 to 30 students graduating in May. Where do the students go after graduation? 20 to 25% go to PhD programs. Some of them come to Penn. This was asked by a student. Few of them, very few, but others go to top-rated programs, not only in the US, but also in Europe. And we are proud to write recommendations for them. As Dr. Khanna said, that I write a lot of recommendation letters, and I'm very happy when students not only go for PhD, but also get great jobs. One of our students who graduated last year is now has a permanent employment, has now a full-time employment in Intel. I'm sorry, many of our graduates go to applied materials. These are the two tech-heavy industries that have traditionally taken our students. But now, of course, students go to Google, Meta. We have a lot of our graduates in all these companies. And a lot of students also have been very successful in getting good internship opportunities at the end of the first year during their summer. And some of them end up getting offers right at the end of their internships because they have done a good job. The technical details of how to get a master's degree, they're all listed on their website. There are 3 routes, and there was a question regarding this. Some students take 10 master's level courses, 6 of which need to be MSE lecture courses, and there are lots of courses that are listed here and in the course catalog. Some of the students do 8 lecture courses and 2 independent study with professors, not just in material science. They can virtually work with any professor in the school of, in physics, chemistry, or school of engineering on anything that is scientifically related to material science. And that has been very helpful. Or about 15% of students pursue a thesis option. And there was a question earlier whether the thesis option could be converted to this. Yes. There is total flexibility. These tracks are only decided around the 3rd semester. And if in the 4th semester, the student feels that thesis is not what the student wants to do, the student can very easily take an extra course and just retain the independent study or research credits and graduate. All students are offered the opportunity to take 2 free electives from Wharton or from other schools. Some of them use that, some of them just take 10 material science courses just because they love the subject and want to get as good a foundation as possible. I mentioned earlier that students are welcome to do research with any member of the graduate group or even at large at Penn, as long as it's related to material science. And the information about who are the faculty from School of Arts and Science, School of Design, School of Engineering, of course, who form the MSc graduate group can be found on our website in detail. A few names are listed here. And as you can see, we have faculty from ESC and so on. Mark Allen is the director of the Singh Center. And this is a photo of our recent graduates from May 2023. This is not all the graduates. When the photo time came, only a few students were available, so we took this picture. And I'm very happy to say that many of them have very good jobs and keep in touch. I'm going to give you a little bit of glimpse into what the students liked about the program when they answered anonymously an exit survey. And as I mentioned, these were our graduations in May and August, and 1 student graduated in December with a dual degree, and 8 of them won CEAS awards. And so the first question that I asked them was your overall experience, academic, social, living at Penn, and specifically at Penn MSc. Kindly describe how satisfied you are, and you can take a look at this. The worst answer was good. And there were some very detailed answers. Great, overall experience was very good, and so on. And on the next page, more students answered, and there's actually one more page that I cut off. You can see that it was very positive. They loved the vibrant and lively city of Philadelphia. Philadelphia is almost taking over New York City in the culinary scene. So students enjoy that. And it's not as expensive as New York. So you can read about the comments there. And this was one of the other questions on this long exit survey, your immediate and long-term future plans. And you can see here how many of them had specific job offers before graduation. Some of them were looking for a job, but many of them were also going for a PhD degree at University of Delaware, at Penn, at Brookhaven, Stony Brook, and then BU, TAMU, and so on. So we had a very good year of graduates going very satisfied with their degrees. And this is also a continuation of that. Some of them returned to their homeland to start a company. Some of them joined AI company. And we also get some part-time students sometimes. And so that is the profile. So I want to emphasize here that when you come in as a master's student from outside, there are a lot of opportunities. Penn is a very collaborative place. So our faculty have collaborations with the School of Medicine. We have a faculty, Professor Kyle Vining, who's part-time in MSE, and he's a dentist. He belongs to the School of Dentistry. Everything on campus is within walking distance. And so therefore, students find it very inspiring to go and hear seminars, have research opportunities in various schools. And students also get to participate a lot. There is a Philly Materials Day that's hosted on the first Saturday in February. It's open to kids of all ages, typically between 3 and 12. And you get about 3,000 to 5,000 people with families coming in, and our students do demonstrate projects, and they find it a very interesting experience to interact with children, their parents, an opportunity that's very unique to Penn and Drexel University. Together, Penn MSE and Drexel MSE host this event. There is a lot of our information on social media that all of you are probably familiar with. And I just want to ask, I think I'm probably out of time. So I'm going to stop here and maybe take questions and answers, if that's okay with you.
Yeah. So Dr. Kanta, that was a great presentation. There were a couple of questions specific to material science that came up, so maybe we'll try to answer and then take the more general questions. But
Sure.
before that, I just want everybody to be aware tomorrow we're going to have another webinar on biotechnology masters. So if you're interested, please stay tuned. Keep a lookout for our emails coming out from CollegeNet. So Dr. Kanta, there's a question, I think it's sort of related question, which is it possible to finish the MSc degree in a year?
Yes. So it's interesting. So our PhD students, when they come in, they are required to take 4 courses every semester, at least in the first semester, and then they do 3 + 1 research unit. Some of our master students are driven, and they say we can handle a 4-course unit load per semester and do well. So if a student does 4 + 4, fall and spring, then they only need 2 credits to graduate. And increasingly since the pandemic, a lot of us in the engineering school have been offering some summer courses. And I'm one of the people in MSc who has always offered a summer course over the last 3 years. And I will be offering this summer too. And I've had students take those opportunities and graduate by August, which cuts down on living costs, which cuts down on your overall cost to finance your degree. And yes, so technically, yes, it is possible to start in September and finish by next August.
Indeed. So thank you, Kanta. That's very helpful. I think applies to a lot of programs, but specifically, if you're interested, if you get admitted, to keep a lookout for Dr. Kanta's class this summer. Keep a lookout for that.
But other faculty at MSc in CES also teach summer courses, and our students take that too.
Cool.
And also from the free electives, students can choose summer courses from arts and science or something like that. I had a student who's doing very well, whom you know, Boone. He took a children's literature class because he said, I want to explore writing. So that was a very good experience. So there are courses available that you can take in summer, graduate level courses.
Awesome. So I think there are two questions which is sort of interrelated, which is how does students find RA and TA opportunities in material science? And if they want to do master's thesis, like is there a faculty match or they have to go look for faculty themselves?
Okay, very good question. As Professor Khanna earlier answered about TA, we encourage students to take classes, do well, make an impression on the professor, and then write to them at the end of the semester that they would like to explore TA opportunities for the following year. That's the most common route. Now, it's possible that a student may already have done a graduate level course, which is comparable to the graduate level course here, and may talk to an individual faculty member and offer to be a TA for the course. And if there is need, they can be taken. And actually, in this year of students entering in fall, I believe one of the students has been a successful TA without taking a course, but she just came in with a lot of experience and eager to have that opportunity. And the faculty member was satisfied. And I believe she's continuing as a TA even in spring for a lab course. So such opportunities are without taking a course are rarer. But those who take a course and do well, people like me and any of the faculty here, including Boone himself, we look for the students who did well and tap into them, because TAs are as integral to your course being successful as the instructor. So yes, there are opportunities and they can be sought after. And as far as the thesis option is concerned, no, there is no centralized matching that's made to your faculty member. Students explore on their own. They write to the faculty, and as Professor Khanna mentioned, you read their papers, you try to see what you're interested in a faculty member's research. And most faculty, if students start writing in September, as soon as they arrive, they may not get a reply because we are all settling into the rigors of the program. And if they wait patiently, by November, most faculty would reply and ask them to meet with them. And then they evaluate the interest and see if the student has potential, and they might recommend their course to see how the student does. And then those research opportunities come. So most of them are done by the students themselves. There is no centralized system. Occasionally, students come to me for advice, and I can tell them about other faculty in other departments, depending on what they are interested in. I've recommended students to MEME, to ESC, and so on. So those opportunities, they may not immediately know because every department, all other departments are bigger than MSE. The faculty pages are dense. You may not know. And sometimes I would be happy to recommend a student. So
Cool. Thank you, Kanta. And so this is a related question, I think applies to all programs, but it's actually a follow-up to Kanta, you're mentioning 4+4+2, which is completing the master's in 1 year. Is it possible, if somebody's interested in the thesis option, is it feasible to do 4+4+2?
Yes, because then they would do the 2 research credits either over the summer, or so for a thesis option, normally students do 7 lecture courses, 2 research credits, and maybe 1 independent study to get an acquaintance with the research topic. So what the student might do to plan beginning spring is to, by springtime, they have a good idea what are the courses that are going to be offered. So if there are going to be some MSc courses that are offered, lecture courses over summer, they might keep that for the summer and start their research activity. So yes, it is possible. They just have to tailor it. There are various routes, as sometimes students can do both their research credits over the summer 3 months and write a thesis. That's possible. Yes, there are different avenues. Research credit is the same as taking a lecture course, but it's more individualized and the faculty member evaluates.
That's great. So we have about 4 minutes. I'll try to squeeze in 2 more questions. I have to say, apologize. There were some questions on programs not presented today. I wanted to get to them. I don't think we'll have time. But if you go on our website and our YouTube, you can search for Penn Engineering graduate admissions. You can watch, for example, webinars on CIS and data science. Apologize in advance, I couldn't get to those questions. But I'd like to take 2 general questions that apply to all 3 programs. The first is a question, is it possible for a master's students to TA an undergraduate class, or when they're here, they can only TA graduate classes?
I'll just go first because I mentioned of a specific case of a master's student coming from outside the US. She successfully TA'd an undergraduate lab course in the fall, and I was just told that she's going to continue as a TA for the second part of the lab course in spring. So yes, it is possible.
Cool. So there was some questions on the difference between capstone versus independent study versus thesis option. Do any one of you have a quick two-minute answer to this? Like, what's
So
the key difference?
I'm happy to give that answer because I think Robo is the first capstone project. So I would say that the way to think, so independent study is basically, this is you studying about a particular topic, right? And so usually you will have a faculty advisor that will guide your study and your learning. Thesis is about doing novel independent research, okay? And then, so if you think about research, research and development, you would have this spectrum of more development focused projects versus more research, fundamental research projects. So I would describe capstone as something that is potentially more on the development end, that is really about, taking the ideas that have been shown to work, but maybe it needs to, you need to do some work in order to actually implement it, and integrate it into a particular system. And so those kinds of projects are more suitable for capstone.
Thank you, Dr. Ani. So I think we're almost out of time. I wish there are more questions coming in. It's so wonderful to see all the interest from students. And so I'd like to thank all of you for being here. We very much look forward to your applications. And for whatever questions we couldn't get to today, please visit our website, our YouTube channel, or feel free to email any one of us, and we'll be happy to answer your questions. I would like to thank Dr. Tanya, Dr. Anisia, and Dr. Kanta for being here today. So I wish everybody all the best in your application, and look forward to seeing them. And hopefully see some of you here in fall.
Thank you.
All right. Thank you all.
Thanks.